In this video, we're going to look at two story problems that utilize the law of cosines. It's best to watch some of the earlier videos because I'm not going to explain things as in depth as if I was teaching this for the first time. So please watch parts 1, 2, or 3 to kind of get yourself familiar with the law of cosines. So here we have a situation where you're traveling from Naples to Key West. It's 150 miles if you go straight there. But unfortunately what happens is that you get off course by about 20 degrees, and after 4 hours at 15 miles an hour, 4 times 15, you get 60 miles off course until you realize that this black dot that's right next to angle A here, at this black dot you need to now change direction and go towards Key West. So part A asks, find the distance you are from Key West. So we're trying to find this dashed line that goes from the 60, right at the end of the 60 mile mark, from this black dot to the Key West dot. So what are we given? We're given two sides of our triangle. The blue sides are given, the 60 and the 50, and we know the angle in between them. So we actually know a side angle side. We can't use the law of sines for this because we don't know a corresponding opposite side to its angle, so we can use the law of cosines since this isn't a right triangle either. So let's do that. Let's find our side x. Now, if we're trying to find side x, we have to use that as the side we want to find in our law of cosines formula. So this would be x squared equals the two squared sides of the other sides, which is 60 and 150. Then after you do the squared sides, then you have to subtract 2 times the product of those sides, and then the cosine of the angle that's between the two sides. And in this case, or the angle that also creates this x squared, let's put the 20 in right there. Now, I have typed this whole string into my calculator, so now I have x squared is equal to a decimal approximation of 9,185.5. Now the decimal's longer than that, but then I have to take the square root, and after I take the square root, I get 95.84, or 95.8. And that is going to be my answer for x. So x, the distance I am away from Key West when I got off course, was 95.8 miles. So the next question is, find the angle you need to correct your boat. Now, one of the key ways that most students would try to solve this is with the law of sines, because we now know our sine right there of 20 degrees. So we know the sine of 20 degrees is across from its side of 95.8 miles. Now what I'd really like to find is this angle A. I'd like to find this angle A right here. So what I'm going to do, I'm going to try to find this angle theta right here. Well, what's nice is if I can find this angle A, I could subtract it from 180 degrees to get theta. Because a straight line adds up to 180 degrees, so if I find this angle A, which I can do so because it's inside the triangle, I should be able to subtract it from 180 to get theta. Well, this little strategy can get you into a little bit of trouble if you're not actually paying attention. Because we do know side length A, which is 150, and we're going to use our cross multiplication to figure this out. So I'm going to multiply in my calculator the sine of 20 degrees times 150 divided by 95.8. Now if I do that, I will get a decimal. The decimal I get is 0.53. Now what I'm going to do is take the inverse sine of both sides, so the inverse sine of A is just A, or the angle we're trying to find. The inverse sine of the decimal ends up being 32.4 degrees. Now 32.4 degrees, if we're trying to find angle A, check that out. Doesn't angle A look bigger than 32.4 degrees? In fact, what we just did is we did a side-side angle problem, which came up with something called the ambiguous case. Because when you do a side-side angle problem, you have to double check to make sure that your angle actually fits the problem you're working with. Because this is a situation where there could be two possible answers. This is one possible answer of 32.4 degrees, but the actual answer for angle A is the supplement of that, which is subtracting it from 180 degrees. Which is the trick that I taught you back in the Law of Sines video number 3, the ambiguous case, where we had a situation where we had to try to figure out what the possibilities of side-side angle could be. Come to think of it, maybe it was part 4, but either way, the title was the side-side angle, the ambiguous case. So now we do our subtraction here, and we end up with 147.6 degrees, which happens to be angle A, 147.6 degrees. Our theta, which is the angle we're trying to find, because it says in part B, next find the angle that you need to correct your boat, that's literally theta. That would be the supplement of 147.6, which gets you back to this answer for theta. So this technically is theta. Theta is 32.4, not actually A, where A is 147.6. So this is a situation, 32.4, where if you actually are just taking your answers and not paying attention, you would make a pretty big mistake on this, but luckily the picture was there. If the picture wasn't there, I would not have used the law of sines. I would have used the law of cosines again, because that way I would have made sure to get the correct answer other than the ambiguous case using the law of sines. So this example is perfect to illustrate the fact that after doing the law of cosines, it is dangerous to do the law of sines unless you're paying attention and have a picture. For our final story problem of this video, we're going to look at this situation about flying from Fort Myers to Orlando. So we need to figure out just how long it is. So Fort Myers to Orlando, we're just going to call that side A. We'll use a lowercase a, and that means that this angle here is going to be capital A. And we can find this angle A because we can take the supplement of 150 degrees, or sorry, 50 degrees, which is 130 degrees. Because the supplement of 50 is 130, which means that they add up to 180. So 130 and 50 are supplemental angles. All right, so what are we given? Well, we are given the 100 mile and we're given the 150 mile and the angle between them. So this is a side angle side situation. So since we have side angle side, we are going to use the law of cosines. So a squared is equal to b squared plus c squared minus 2bc cosine a. And we have now a squared is equal to, let's go with 100 squared plus 150 squared minus 2 times 100 and 150 cosine, and we know this angle is 130 degrees. Okay, so I'm going to plug all that into my calculator, and I get a pretty hefty number, 51,783.6. Then we take the square root of that, and a is equal to plus or minus, but we don't worry about the minus, 227.6 miles. So this side A is 227.6. So now what we need to do is find the bearing the pilot should use to fly directly from Fort Myers to Atlanta. So this is the angle that we're looking for, and we'll call this angle B. Now, I'm going to use the law of sines. I know you might be thinking to yourself, why would do the law of sines when it caused problems in the last problem? Well, we have a picture, and we're smart enough to figure out if that answer looks and seems reasonable, and we'll also test for the ambiguous case just in case. Because if I go the sine of B, which we're trying to find, the angle B, over 100 is equal to the sine of 130 divided by 227.6, we're now going to cross multiply. 100 times the sine of 130 degrees divided by 227.6. Please make sure your calculator is in degree mode. Then we get sine of b equals the decimal 0.34. If I take the inverse sine of both sides, this is going to give me just b. And on the other side, if I take the inverse sine of 0.34, this gives me an answer of 19.7 degrees. Now, does this angle look like it's 19.7 degrees? Well, to the naked eye, it sure does. If I subtracted this from 180 to test the ambiguous case, it would give me an obtuse angle, and since I already have one obtuse angle in the triangle, there's no way a second obtuse angle could make a triangle. Fun fact, of course, triangles can only have at most one obtuse angle. So, this is my answer to the problem. Because I had the picture to help me, but also I had the perseverance to test the ambiguous case, this side-side angle situation didn't mess us up like I did in the previous problem. So always rely on the law of sines, but if you ever have to find an angle using the law of sines, please beware of the ambiguous case.